right, so another part of Unit 3 is angles, types of angles. So we have supplementary angles, which means you add them together and they equal 180. Complementary angles, you add them together and they equal 90. Vertical angles are congruent. And so for number 17, it says consider the diagram of supplementary angles. So they're supplementary. That means if I add this angle of 128 plus this angle, 5x, it will equal 180 because remember supplementary angles form a straight line. Now I have a two-step equation which goes back to Unit 2. I'm going to subtract 128 from both sides. 180 minus 128 is 52. Now I have a one-step equation, which goes back to 6th grade math. So I'm going to divide by 5 on both sides. And x is 10.4. So the question asks, what is the value of x? X is equal to 10.4. If it were to ask you what is the value of the angle, 5x, then you would have to plug that 10.4 back in and solve for it. So make sure you read what is the question asking you. Is it asking you for the value of x, or is it asking you for the angle measurement? That's two different questions. You need to make sure you read it carefully so you know what the question is asking. The next one says, consider the figure composed of two rectangular prisms. What is the volume of this figure? To find the volume of a rectangular prism, you multiply the area of the base times the height, and multiply that by the height of the rectangular prism. So this base is 8 times 10, and the height of the prism is 2 for the bottom prism. 8 times 2 is 80. 80 times 2 is 160. So for this bottom rectangular prism, the volume is 60. Now I need the top rectangle. The base is 8 times 2, and the height of the prism is 6. 8 times 2 is 16. 16 times 6 is 96. So the volume of the whole three-dimensional shape is 160 plus 96, which is 256 cubic inches. All right, so the next unit is Unit 5, which is statistics. That's all about biased and unbiased, random sample, voluntary sample, convenient sampling, all of that stuff. So 19 says, a gym teacher at Jackson High School wants the school to have a new team sport, soccer, lacrosse, or rugby. She will take a survey to determine which of those sports most students prefer. Which population would provide a random sampling for the gym teacher to use? A, all students at the school who are 16 years old. If you only choose 16-year-olds, then you're not including the other ages at the high school, so it's not A. B, all students who buy lunch on Friday. If you only pick the students who buy lunch on Friday, then you're not including the kids that bring their own lunch, so that is not random. C, half the students who play only team sport at school. If you choose the kids that play a sport to choose the new sport, you're only asking the athletes. So you're not asking the kids that just go to the sporting events. You're not asking the kids that are involved in clubs instead of sports, whatever. That's not random. That would be bias. D, every third student arriving at school. Yes, that is random. So out of these options, D would be the best survey or the best way to find out what kids prefer. Listed below are the quiz scores for randomly selected students in 2 7th grade classes. Based on the samples, which class generally has a higher quiz score? So we're going to find the mean of both classes. So for class A, to find the average or the mean, you add them all together and divide by how many numbers you have. So I have 99 plus 75 plus 84 plus 70 plus 86 plus 80. That is 494. They use 6 quizzes. So when we divide by 6, that gives us an average of 82. And I'm rounding to the nearest whole number. For Class B, that is 85 plus 83 plus 87 plus 90 plus 85 plus 82, which is 512, divided by 6 is 85. Of course, I'm rounding. Based on the samples, generally speaking, Class A has lower scores. This is Class A. This is Class B. So Class B has higher quiz scores. It says use the measures of center and or variability to justify your answer. Remember, measures of center is your average, and measures of variability is your range. So we found the average. Now let's look for the range. The range for Class A is 99 minus 70, our biggest number minus our smallest number. And for Class B, that is 90 minus 82, which is 8. So I can infer that Class B has higher quiz scores because they have a higher average and a smaller range. That means their quiz scores are closer together compared to Class A. Class A, if you just look at it, you see this 99 and you would think automatically that they have higher quiz scores, but that's really more like an outlier because you have all these C's and B's. Whereas Class B, they're closer together and these scores are higher than Class A. So the mean for Class B is higher and the range is lower than Class A, which means they consistently or generally have higher quiz scores. All right, number 21, consider the 2 box plots. Which statement is true? Plot F has a greater range than plot H. So to find a range, you find the upper extreme and subtract the lower extreme. 90 minus 10 is 80. 90 minus 10 is 80. That is not true. They are the same. Each plot has more than 25% of the data greater than 50. So each little area of a box and whisker plot is 25%. So for plot F, more than 25% of the data is greater than 50. For plot H, not even 25% is greater than 50. So that is not true. For C, the median of plot F is greater than the median of plot H. The median is the line in the middle. That's right there at about 65. The median for plot H is 40. That is true. And the spread between the upper and lower quartiles of both graphs is 10. The spread between the upper quartile is about 71 and 55. That is not 10, so that is not true. The answer is C. All right, the last thing for Unit 5 is dot plots. What is the difference between the medians in plot A and plot B? So to find the median, you order your numbers from least to greatest, and then cross them off from left to right until you find what the smallest one is. So my 1 and my 10, 3 and 10, 3 and 9, 4 and 9, 4 and 7, 4 and 7, 6 and 7, and I'm left with 6. For plot B, 1 and 10, 2 and 5, 2 and 5, 3 and 5, 3 and 4, 3 and 4, and I'm left with 4. So the difference would be 6 minus 4. I found my answer by ordering the numbers numerically and finding the number in the middle and then subtracting the two medians. So the difference between the medians is 2. I found this by ordering the numbers numerically to find the number in the middle. Then I subtracted to find the difference. Part B says which plot has the greater mean. So for the mean, I'm going to add all these numbers together. I have 1, 1, 2 3s, that makes 6, 4, 8, 12, 6, 12, 7, 14, 21. I'm just adding all these dots. 9, 18, 10, 20. So now I can add these numbers together. Just makes it a little bit easier. If you need to add them all separately, you can do that. This is just the easier way. When you add them all together, you get 90. There are 15 total dots, so that gives you an average of 6. For plot B, that's 1, 4, 3, 6, 9, 4, 8, 12, 16, 20, 5, 10, 15, 10. Add those all together. 1 plus 4 plus 9 plus 20 plus 15 plus 10 is 59. When you divide that by 15, it rounds to 4. The plot that has the greater mean is plot A. I added the numbers together and divided by how many numbers there were to find the average. All right, so for Unit 6, this is all about probability. The table shows the results of randomly selecting colored marbles from a bag 40 times. The marble is returned to the bag after each selection. Based on these results, what is the expected probability of randomly selecting a green marble from the bag? So green is 8 out of 16 plus 8 plus 6 plus 9 plus 1. So 8 out of 40. Divide that, and that is 0.2. It is B. What is the likelihood of randomly drawing a purple marble if a bag contains 14 blue and 14 purple? It is neither likely or unlikely. It is as likely to pick purple as it is to pick blue. For 24, a number cube with faces numbered 1 through 6 is rolled 15 times. In theory, how many times would you expect to roll a number less than 5? So there are 1, 2, 3, 4 numbers less than 5. So there is a 4 out of 6 chance when you roll it one time that a number will be less than 5. Multiply that by the 15 times that you roll the dice. 4 times 15 is 60 out of 6. And when you simplify that, that gives you 10. So out of 10 times, or out of 60, 15 times rolling it, 10 of those times you should land on a number less than 5. 26. The 6 sides of a number cube are labeled 1, 2, 3, 4, 5, and 6. You flip a coin and roll a number cube. In theory, what is the probability that the coin lands on heads? And you roll a number greater than 4. So, the probability of landing on heads when you toss a coin, you can either land on heads or tails. For a number cube, the probability of landing on a number greater than 4 would be 2 out of 6 times. So 1 out of 2 times 2 out of 6. Probability of landing on heads times the probability of landing on a number less than 4 or greater than 4 would be 2 out of 12, which is 1/6. That is B. For 27, part A will be B, and part B will be B and C.